The second sampling is called systematic random sampling. And now, why this is called systematic random sampling? It is a random sampling, but it is simply called systematic. Systematic means, I am telling you, suppose we are having the 100 candidates, and I have to select 10 candidates from there. So what I do, I divide the population into 10 portion. uh, 10 divided by 10 is equal to 10. So I divide the population into 10 units, and from here I apply simple random sampling and pick one number. Suppose my number is 6. So then all number will be systematic, like 16, 26, 36, 46, like that. So if you collect the sample like this, so you will collect the data from 6%, 16%, 26%, 36%. So this method is called systematic random sampling. Right. So you can see that after 2, you will go to 5, leaving 2 numbers. After 5, you will leave 6 and 7, go to select 8, then go leave 9 and 10, select 11. So this is simply known as systematic random sampling. Okay. And I'm giving one more example. Like suppose I have some population of 100 units in a university. Suppose there are 1000 professors or teachers, and I want to select only uh, let's say 20 teachers. I want to select the 20 teachers from 1000 teachers. So I will do one thing. I will divide 1000 by 20, and which is equal to 0050, 50, right? So it means the population is divided into 50 parts. So 1000 divided by 50, right? Okay. So first 50, 100, this is 50, 1 to 50, then 100, right? Okay. So 50 is the distance of each subgroup, and then I will pick any particular number from here, from lottery method. Suppose this number is coming to be 17. So now the next number will be 67, then 117, then 167, like that. So similarly, you can collect the 20 people from the sample. So this method is known as systematic sampling. So I hope it is clear, not very difficult. And after systematic sampling, but practically I have not seen this sampling in any PhD thesis. So it is kind of rare case in for a PhD thesis, because we never have the list of the people from where we can select. Okay, now stratified random sampling is very popular sampling. Stratified random sampling, you try to understand that suppose we are having some groups. Like for example, I can say these are the young people, these are the middle-aged people, and these are the old people. So I believe that there is some kind of homogeneity in the young people, there is some kind of homogeneity in the middle group, and there is some kind of homogeneity in the old group. So the strata, the stratified word come from the strata, and strata means homogeneous subgroup. So it is called homogeneous group. Okay, so strata, you can see that strata should be mutually exclusive and collectively exhaustive, and there is some homogeneity in the strata. So basically, when we divided the, for example, when you take the data from the employees of a company, the employees are divided into different groups. Like for example, junior executives and middle managers and the top managers, right? So this is one of the classification in the industry, and you can decide that I will collect 50% data from the junior managers, 30% data from the middle managers, and 20% data from the top managers. So we believe that junior managers will be a strata which consists of homogeneous people, and middle managers. Similarly, if you go to a bank can be divided, and the bank employees can be divided as a staff and managers. So staff is 80% and managers are 20%. So you can decide on the basis of the designation also. Similarly, if you take the universities, so universities are decided into three groups: central university, state university, private universities. Right? Normally, we divide the universities into like this: central universities and state universities and private universities. So we believe that the staff who is working with central university, they have similar kind of behavior. Central state universities some different kind of behavior from central, and private universities the behavior is different. So the central university is considered as one strata, state university is considered as another strata, private university is considered as another strata, and private institutes can be considered as another strata. So we divide the population into different strata and then go for a random sampling. So after dividing the population into different strata, then we decide whether we go for systematic random sampling or simple random sampling. So this method is called stratified random sampling. There are two types of stratified random sampling. One is called proportionate stratified random sampling, and now you can see here there are two types of stratified random sampling: proportionate stratified random sampling, disproportionate stratified random sampling. Because normally we will go for a proportionate stratified random sampling as compared to disproportionate random stratified sampling. Like for example, I'm giving you uh, in a university, six assistant professor, three associate professor, and one professor. Some this kind of ratio is there. So we can say that 60% of the sample size should come from the assistant professor, 30% is should come from the associate professor, and 10% should come from the professor. So this is called proportionate stratified sampling, because we are maintaining the proportion. So if we are not maintaining this proportion, then this is called disproportionate stratified sampling. So this kind of example which is coming into my mind when we decided to go for stratified random sampling. So this concept is a very easy concept. I hope it is understood, and we can move to the next part. The last sampling in probability sampling is known as cluster sampling. In stratified sampling, we divided the data into strata. We divided the population into strata, and all these strata are homogeneous. But the cluster sampling is different. In cluster sampling, we divided the region into different subregions. For example, whenever we call NCR, whenever we call NCR means National Capital Region. So it is having some regions like Delhi is the part of NCR, then Ghaziabad is a part of NCR. Then Bahadurgarh is a part of NCR. Then Noida is a part of NCR. Then Gurgaon is a part of NCR. Gurgaon, or कौन सा Faridabad is a part of NCR. Faridabad is a part of NCR, right? So maybe I forget one or two cities, but these are the popular areas of NCR. So now you divided the area, you divided the region into different clusters. So these are the clusters, and then you decide that on the basis of proportion, 50% is data we are collecting from Delhi, 10% data we are collecting from Ghaziabad, 10% data we are collecting from Badurgarh, 15% data we collected from Noida, 15% from Gurgaon, and क्या बचा, कुछ भी नहीं बचा, 0%. So this is my calculation is wrong, but we decided like this. So if we do this kind of criteria, if we use this kind of criteria from sampling, right, this is known as cluster sampling method. Now one thing which is different between stratified and cluster sampling: strata is always homogeneous. strata Strata is homogeneous, and one cluster is heterogeneous because within strata there is some similarity between the respondent, but in cluster you can't say that every people is equal. There is a similarity in different people. So this is called cluster sampling. This is also known as area sampling or geographical sampling, like this. In some books, they call it area sampling, but the standard name of the sampling method is called cluster sampling. So cluster sampling is based on the area, and the stratified sampling is based on only the homogeneous subset. So after understanding the cluster sampling and the stratified sampling, because I am also answering those questions which normally people ask me when I take the lecture, that what is the difference between stratified sampling and cluster sampling. Stratified sampling is a kind of homogeneous sampling, homogeneous subgroup sampling, and cluster sampling is heterogeneous subgroup sampling, because all clusters within cluster there is a heterogeneity, but within strata there is a homogeneity. And again, cluster sampling can be proportionate and unproportionate, disproportionate. So these are the different kind of samplings, and these are the different pro and cons, strength and weakness of the probability sampling and unprobability sampling. But I can tell you one thing, because on the basis of my experience, I can say the in PhD thesis and the research papers, the meanwhile you can read all these things, but I am telling my experience to you. After handling so many research projects, this is my conclusion that if I take the example of 200 research projects which I have handled in my life, in 2000 research projects, quota convenience sampling is the most popular we applied. Quota judgmental sampling. Quota judgmental sampling is the most popular method we applied in the research projects. After that, if I say you, simple judgmental sampling is the second most popular sampling method which we used. And in some cases, we also used convenience sampling and snowball sampling. And in hardly one or few cases, we applied stratified random sampling. So these are the and cluster sampling also, because sometimes we divided the region into different clusters, right? But if I rank them, the number one is the quota. Basically, we know we don't apply one. We basically mix all these. So first is quota judgmental sampling. Then we go for snowball sampling, then convenience sampling, stratified random sampling. If you have the sampling frame properly, sampling frame, then cluster sampling. So the most popular are these two: quota judgmental sampling and the judgmental sampling. So I also recommend, whenever somebody write convenience sampling in their thesis, I always say that don't use convenience sampling, rather you should use judgmental sampling, purposive sampling, or the mix of the sampling, like quota judgmental sampling method. So I hope now you have some idea about all the sampling methods. Now I am moving to the most important part of the lecture, and I did a quite good research on the sample size. So you can see in the slide also. So now the biggest problem in sample size is that how to decide the sample size. And there are many formulas related to the sample size. There are many principles who are deciding about the sample size, and there are many theories which also explain the determination of sample size. But actually, what I found in the practical ground, that still most of the researchers are confused about the sample size. And even we are knowing some formula, but everybody know that there is a formula for determining the sample size, but again clarity on the sample size formulas are not there. So I decided to take this topic also along with the sampling distribution, sorry, sampling design, so that we can discuss on this. So let me explain. I'm going to explain you the some popular concepts of sample size. So number one, we have to decide the confidence level, first of all, confidence interval approach, right? And in deciding the confidence interval, we decide the variability of the population, that how much is the variation in the population. And if there is a higher variation in the population, it means you have to increase the sample size. If there is a less variation in the population, it means the sample size is less. For example, I'm telling you, if some medicine is applicable on 10 people, it means that medicine should be applicable of 100 people, 1000 people, 1 lakh people. So in medical science, variability is very less. So you can even try on the 10 patients. So whatever result you are getting, the same result you will get on 100 people, 1000 people, and 1 lakh people. So you can understand what is the meaning of variability here. So but if the population is if the population is having large variation, it means you are going to study on more. Like in case of income, in case of consumer, in case of car users, in case of mobile phone users, there is a huge variability. So you want to take the sample size larger for studying this. So in marketing, we know that there is a lot of variability in the consumer behavior. So normally we go for 500, 600 sample size. Similarly, in some areas, the variability is too high. So your sample size may go up to 1000, 2000 also. So variability is one factor which decides about the sample size. Then confidence level. So what is your confidence level in the study? If your confidence level is 95%, then the sample size may be different. If your confidence level is 99%, then the sample size will be different. So higher the confidence level, more will be the sample size. And then the third concept which we use in the formula is the margin of error. So what is the precision is you want in the sample size? So basically we take three things here. Number one is standard deviation. Number two, the confidence level, which is denoted by Z. Z at 95%. If my confidence level is 95%, I will use the Z value at 95%, which is equal to 1.96. Okay. Then margin of error, normally we keep 5% in almost every study. 5%, this 1.96. So you can see that when we apply the formula, this value is constant, this value is constant, because margin of error we always keep 5%, confidence level we always keep 95%. So the problem lies in only the standard deviation. So practically, if we apply, this is the formula we are going to apply, and in this formula, n is the sample size, z is the confidence level, and sigma is denoting the variance, and e is denoting the margin of error. The problem in this formula, you can see, the margin of error is always 5% we keep, and this is the range 1 to 5% you can keep without any problem. And sigma and z is always constant. This is values 1.96. Now you have to decide what is my variation in the data. So normally this variation we keep 50%, 0.5, right? With this variation we can find out the value of n, right? So if you solve this, you will get the value. Solving is not a problem. If with these assumptions, if I calculate this 1.96 square upon zero point 0.5 square upon 0.05 square, so you will get value around something 350 and something like that. So by changing the standard deviation, you can vary your sample size, right? Because you cannot change this, you cannot change this. Only thing which you can change is 0.5, the standard deviation. So how much standard deviation you are allowing in the sample size, right? You are assuming in the population, so that you can take here, right? So this is also based on assumption. We are not calculating this standard deviation. We are assuming this. So your assumption may lie from zero point 0.5 to 0.07. So in most of the studies I have this range of assumption, and if you want to increase this assumption, it means sample size will increase. And if you keep it 0.5, you will get around 350 and something like that. So I can show you one table which is given by Bartlett. I'm showing that table to you. Oh, okay. Yeah, this is the table I want to show. Basically, this is a table, and this table is very popular table given by Bartlett. There was a professor Bartlett. He calculated all these things and gives you the value of sample size. You can see that if my confidence level is 95% and my margin of error is 5% and my population size is 1000, so the sample size should be 278. So now the problem with this Bartlett table, the maximum value of sample size is 384. You can see here. So even if your population size is 3 crores, I think this is 30 crores. If your population size is 30 crores, the sample size of 384 is sufficient. So I know that most of the research scholar, they quote this table. This table is known as Bartlett table of sample size, and according to this table, if even if you are having the population of 30 crores, right, then the sample size of 384 is sufficient, assuming the confidence level of 95% and with the margin of error is 5%. So that's rather calculating the formula, you can report this table also. So in any study, uh, this three sample size of 384 is found to be sufficient. Okay, so I hope you understand this formula. And the second thing, there are some formula are also there. This is the formula when population proportion is known, when the population proportion is not known. For example, you know that 30% of the patients are having vitamin D less than 20. So here you know that in India, only 30% of the people are having vitamin D more than 20. 70% of the people have vitamin D less than 20. Right. So when you know this kind of proportion, you can go for this method. Only thing again in this formula or in this formula is that Z value is constant 1.96. Z is always 1.96 and E value is always 0.05. Only that you know the proportion. So if you know the proportion of your respondent, you can apply this formula also. So there are only two formulas I found on the basis of formula. So sample size on the basis of formula can be collected either by this or by this. So this method is based on the variability of the population, and this formula is based on the proportion of the population. So it depends upon your area whether you are going for the variability or you are going to the proportion. You can choose your formula accordingly. So other things, now I'm telling you the most popular method which are used by uh, the public. The first is called Nanelli principle. This is also quoted by different people, and this Nanelli principle say that if count the number of items in interval scale. So simply count the number of items, right? So according to the Nanelli principle, count the number of items, count the number of statements in interval scale, in interval scale, and after that multiply with 10. So whatever you will get, this will be the required sample size uh, of your study, especially when you are going to apply some parametric test or when you are going to apply the structural equation modeling or these techniques, then your required sample size should be the 10 times of each scale. Okay, now you can see that there should be, according to the Nanelli principle, there should be at least 10 cases for each item in the instrument being used. So when I say instrument, it is a measurement scale. So this is the concept which is given by Nanelli principle. Thus, if we go by this assessment, and overall sample size of around 450 would be deemed sufficient, as in totality will deal with around 45 items. So if you have 45 items in this scale, the required sample size should be 450. So this principle is also quoted by many research people that because my criteria is followed by Nanelli principle, so my sample size is right. So whenever I meet somebody, some research scholar, I always recommend to justify your sample size with any of this method. Either you go for the formula method or you go for by these principles. Then second, I always suggest that this KMO estimate you should calculate. So if you are using some instrument where you are having some interval scale variables, so find out the KMO estimate. KMO means Kaiser Meyer Olkin estimate. So KMO estimate should be greater than 0.7. So any KMO value greater than 0.7 is fine. If it is more than zero point 0.8, it is meritorious, and if this value is greater than zero point 0.9, then you can say my sample size is marvelous. So I suggest you to anybody who is writing a paper or doing research, so kindly estimate your KMO so that you can say there is enough variation in my data, there is enough variations existing in my data set, and which is sufficient for the study. So this is called KMO estimate. Now I am surprised to read the book called Business Research Methods, given by the Zygmunt. So Zygmunt say that even if you are using the sample size and you and your guide are satisfied with your sample size, so don't go to any formula and all. Only thing is that if your guide is satisfied, if other experts are saying that the sample is representative, so it is a subjective issue, subjective criteria. Why it is called subjective criteria? Because if subject experts say that your sample size is adequate, it means your sample size is adequate. That's it. There is no logic behind it. If or I can say that if 10 experts, if 10 subject experts say that your sample size is adequate, it means your sample size is adequate. So there is no argument in this, right? So sometimes we take the help of the experts and ask them, can I say my sample size is representative? If yes, it means my sample size is representative, no argument. Okay, so then we use Bartlett table, sample size determination table, and I frequently suggest to use this Bartlett sample size determination table, because most of the time you justify your sample size using this table. Okay, recently I also discovered this criteria from the literature, that is called Bentler and Chow criteria. Now the Bentler and Chow criteria, because in some cases we found that the sample sizes not fulfill the other criteria, so we are looking for any criteria which we can report. So we found in most of the research papers we have this Bentler and Chow criteria. This Bentler and Chow criteria say that if your data is normally distributed, so kindly read this line. So this line is important here. If your data is normally distributed, then sample size of 5 cases is also enough. It means if your data is normally distributed and if you have 5 cases for each scale variable, 5 cases for each scale variable, then also you can say your sample size is adequate. So that's why we also reported, because in a recent study, there is a study on the middle level managers of the IT sector companies, and we found that we hardly collect the data of 198 people. So now the problem is that is 198 is sufficient? Because 198 is not satisfying the criteria or other criteria, and we have challenged to prove that the sample size of 188 is also sufficient. So then we adopted this criteria, and we mentioned this criteria that according to the Bentler and Chow criteria, which is a very established criteria, if my data is normally distributed, if I prove that if my data is normally distributed, that the 5 cases for each scale variable is also sufficient. So then we reported this criteria, and the thesis was successfully defended and no problem come, right? So this is my end of the lecture, and I shared my experience with you, because this topic is very complicated topic. and seems to be easy, but I know that this is the most problematic topic in the thesis or a research paper. So we have to deal this topic very carefully. So I shared my experience with you, whatever I know about the sampling and sample size, and so you should be very clear on the issues that we discussed, especially sampling frame, especially sample size, judgmental sampling, quota judgmental sampling. So uh, from my side, it's over. And next 5 minutes, I want to take some queries that you are asking. So let me see the queries in the chat box, and randomly I will take some of the queries. Okay. So like one participant asked that how to calculate the KMO test. So I would like to tell you that when we do factor analysis, when we do exploratory factor analysis, and in that SPSS gives you one option of calculating the KMO. So you can tick on the KMO while doing the exploratory factor analysis. Then the software will give you the KMO estimate, and KMO estimate will tell you whether this sample size is adequate or not, right? So KMO is very important thing which you should report in the paper and thesis, because it will tell you that how much variation is there in the data. If you have sufficient variation in the data, then it is fine. KMO value should be more than 0.05. KMO, the full form of KMO is Kaiser Meyer Olkin criteria. Kaiser Kaiser Meyer Olkin criteria. ये आपको समझ नहीं आएगा, इसलिए आप छोड़ दो उसको. अब you can type in Google and find out the formula. Okay, so now I'm okay. So yeah, in first in primary studies, these criteria are very important, but in secondary study, if you are doing some secondary study, then these criteria are not important, because in secondary we are not focusing on the sample size. This the sample size or the sampling methods are more important in primary study. Okay. Um, so okay. Yeah, one thing which is clear, that Bentler and Chow criteria you can use only when the variables are normally distributed. Otherwise, you cannot use the Bentler and Chow criteria. Okay. Now, uh, Bentler, Bartlett table you can found in any Google. So if you just type in Google Bartlett table, it is always there. My, so Mergen table I never heard about, but if this table exists, I will definitely read that. Mergen table, देखना पड़ेगा. Great. कभी sometimes participants also suggest. Okay, great. Exit poll is a yes. Exit poll is a example of cluster sampling. Very good. Okay. So yeah, so you are asking me some good books of research. So if you ask me some good books of research, I recommend two books which are my favorite books. One is N.K. Malhotra. N.K. Malhotra is a professor in some foreign university. I think it is he's from Georgia Institute of Technology. And the second book which I recommend is Zikmund, Business Research Methods Using the Zikmund. So these two books I always recommend it, because my most of the learnings come from these two books and some papers. Okay. Mm. Normal distribution, we can test from the test, like for example, we are having Kolmogorov-Ismendorf test. Then we have the Jacob-Miller test. Then we have Shapiro-Wilk test. So these are the different tests we can use for normality. Okay. One question is coming. What is the difference between universe and population? Universe word we are not using in the research. In the research, we call it population. So don't confused by the naming. In in research, we use the population word, not the universe. Okay. मेरे ख्याल से यूनिवर्स में तो चांद तारे भी आ जाते होंगे शायद. uh, so a lot of questioning is coming, but because the time is limited, I tried my best to explain most of the methods. And the next section will be on hypothesis testing. And hypothesis testing, I will cover some important concepts in hypothesis testing. So I know that there are a lot of questions you are coming from your side, and but because of the time problem, I can't answer each and every question. So I hope for the best. Thank you. Thank you very much.
Thank you, sir. I'll just try to, what I'll do is, sir, I'll try to sum up the questions from the chat and we can have one or two questions in the next session, sir.
Okay, don't worry. So,
I'll
not,
just
yes,
go
sir.
through it. I'll just sum up the questions. Usme se any question that we think in common is not being answered, sir, I'll just ask you at the end of the session.
Fine, fine.
Thank you, sir. We meet again at 12:30 for the next session, sir.
12:30.
12 o'clock, sir. Sorry, 12 o'clock.
Okay, okay, okay.
It's
12
11:30
o'clock.
now. We meet again in half an hour at 12:30 for the next session, sir.
Okay, thank
Thank
you.
you, sir. Thank you. Can be done. The different types of samples were discussed. Also, we discussed about the sample sizes, the population, target population, and other such things relating to sampling. Now, in this session, sir will be covering up the hypothesis testing for the purpose of whenever we are thinking about making a project or a research work or a paper presentation work. So, over to you, sir. Thank you.
Okay, so in this session, the topic which I'm going to discuss is hypothesis testing. Okay, so hypothesis testing is one thing that everybody is doing, whether it is a PhD research paper or any research projects. So this is the most important concept of theory building. Whenever we want to develop a theory, we start it from the hypothesis, and if all the hypotheses are tested again and again and give you the same result, after some times it becomes a theory. So I hope you understand that without hypothesis testing, we can't develop the theory. So for theory development, hypothesis testing is the must to understand. So let me try to explain you the concept of hypothesis testing and how we test the different hypotheses. What are the different kind of hypotheses we have? Okay. So in the previous session, I will tell you the concept of statistical inference, right? So statistical inference means when we do some study on the sample and the results are applicable on the population. So similarly, we are doing the hypothesis testing on the sample, and the result can be applicable on the population. So hypothesis testing is a way to draw the conclusion. So conclusion, uh, we designed some hypothesis. We start with some hypothesis and examine this hypothesis, and after that we draw the conclusion, and the conclusion must be applicable on the population. So we conduct all the process in such a way that whatever results are coming, they should be robust, they should not be biased, they can be generalized. So that is the issue in hypothesis testing. So hypothesis, what is hypothesis? So first of all, we understand what is hypothesis. So number one, hypothesis is an assumption which can be empirically tested. So my simplest definition of hypothesis is that anything which we can examine statistically, any assumption which can be tested with the help of a statistical test is called hypothesis. If any assumption which you cannot test with the help of statistics cannot be defined as hypothesis, right? So hypothesis is something which can be tested with the help of statistics. Hypothesis, I hope you understand that. There are two type of hypothesis. One is called null hypothesis, and second is called alternate hypothesis. So what is null hypothesis? So you just see this quote which I take from the Google. So I am, so read this carefully. I am the uh, okay. So there is a problem in raising the hands actually. So I am what is the default, right? So the status quo, I am already accepted, can only be rejected. The burden of proof is on the alternate, I am the null hypothesis. So in this sentence, there are so many things which is mentioned. Number one, the null hypothesis is default, it cannot be accepted, right? So because as a researcher, when I started learning the research, in some of the books and in some of the papers, I mentioned that the null hypothesis can be accepted. Basically, null hypothesis cannot be accepted. The first thing which you should remember, that null hypothesis cannot be accepted. Basically, null hypothesis to reject hoti hai. So null hypothesis is not accepted. A null hypothesis can all be rejected, because if if I say that males and females are equal in their salary, if I make this statement, if I ask that the average income of male, average salary of male is equal to average salary of female, so this cannot be accepted, right? Only this is already there. You can only reject this. So you have to understand the hypothesis in this manner, that we null hypothesis means a status quo which is already there. Null hypothesis is already there, and it is called neutral assumption. Null hypothesis is known as neutral assumption. It cannot be accepted, it can only be rejected, right? So there is a concept called innocent until proven guilty. For example, if we say that the performance of young people are equal to middle age group is equal to old age group, so it is neutral, right? Now, as a researcher, by the observation or by conducting the data, by collecting the data by observation, if we want to prove it, if we want to prove it wrong, then he can challenge this hypothesis, right? And the objective of this hypothesis is to reject it. Most of the researchers want to reject the null hypothesis because they want to challenge it. So the one thing is very clear, that null hypothesis is already there. The researcher objective is to challenge it, not to accept it, right? So if you are doing a research for accepting the null hypothesis, it has no meaning. The objective of the research should be to reject the null hypothesis. So, because I'm saying again and again, why? Because when you mention the hypothesis in the thesis or a research, be careful whether it is a null hypothesis or it is an alternate hypothesis. So, when it is a null hypothesis, your job is to reject it, and when you are mentioning the alternate hypothesis, your job is to accept the alternate hypothesis and the reject the null hypothesis. So, this is one thing which should be very careful, because whenever I see this statement, the null hypothesis can be accepted, it so I know this statement is a wrong statement. So if somebody writes that null hypothesis is a wrong statement, the right statement that null hypothesis is already there, you cannot accept it, right? You should write it cannot be rejected or can be rejected. So this is the first thing which I want to tell you all. uh, so you just see these statements. We begin with the assumption that null hypothesis is true, and any difference between the sample statistic and the true population parameter is due to chance and not a systematic difference. So it is similar to the notion of innocent until proven guilty. Until proven guilty, that is, innocence is a null hypothesis, and we may or may not be rejected. So most of the researcher ask me that can we say null hypothesis is a negative statement? No, no, no. Negative. It is not a negative statement. It is a neutral statement. I always say that null hypothesis is never a negative statement. Null hypothesis is negative assumption. ये negative assumption नहीं होता. So basically null hypothesis is a neutral statement. It is a neutral statement, right? So whatever is there by default, it is neutral, right? So a null hypothesis cannot be positive, cannot be negative. It is always neutral, and the objective of the researcher is to reject it. So I hope after speaking again and again, this should be enter into your mind. So now let's me tell about the alternate hypothesis. So what is alternate hypothesis? Alternate hypothesis is the opposite of the null hypothesis. Alternate hypothesis क्या है? It is the opposite against of null hypothesis. Now you can see in these two diagrams my null hypothesis that if I there are two plants, and if I give biofertilizer to this plant, the growth is better, right? So this is my null hypothesis. Null hypothesis that do not increase plant growth. The application of fertilizer will not change any growth in the fertilizer. So there is no change in the application of fertilizer on the growth. Now I want to challenge this, right? And when I give fertilizer to one plant and not to any plant, so this is not provided, this is provided. So now I want to challenge the null hypothesis and want to prove that this fertilizer will definitely have an impact on the growth. So in null hypothesis, we assume that there is same effect on without and with, and here I want to challenge it and want to say I can challenge the null hypothesis and want to prove that fertilizer have a significant effect on growth. So this is what is null and what is alternate. You can understand null hypothesis is neutral and alternate hypothesis is opposite to it. So alternate hypothesis is the opposite of the null hypothesis. It challenges the status and it may or may not be proven. In is generally the hypothesis that the researcher is trying to prove. So when a researcher start with the null hypothesis, the objective should be to reject it rather than to accept it. So this is my point with taking care of null hypothesis and alternate hypothesis, right? So now read this statement, which makes you more clarity. We never accept the null hypothesis. We either reject it or not reject it. Okay, so one thing which normally people ask me that when we should go with the null hypothesis and when we can go with alternate hypothesis, right? So this is the question I normally face from the researchers, that when null hypothesis can be considered and when alternate hypothesis can be considered. So my experience say that if you are going to apply the technique like structural equation modeling and PLS modeling, right? So all these exercise, all these techniques are basically designed for theory testing. It means when you have some theory, then only you can test it. So when some theory is already there and you want to test the theory in your context, in your respondent, in some technology, so then you can start with null alternate hypothesis, right? So when you are having a significant literature support, significant theory, then you can start with alternate hypothesis because you are testing that. Otherwise, if you don't have any significant literature support, if you don't have any uh, uh, theoretical support, you should not start with alternate hypothesis. You always started with null hypothesis. So I think now you have clarity then when to start with null hypothesis and when to start with alternate hypothesis. And when you start with null hypothesis, your objective is to reject it, and when you start with alternate hypothesis, your objective is to accept it, right? So you have to reject the null, accept the alternate. So this should be the purpose of the research. And you understand at this level that null means neutral, alternate means not neutral. Okay. So these are some of the points which you should know. Like in the process of hypothesis testing, the null hypothesis initially is assumed to be true. Data is collected, examined to determine whether the evidence is strong enough with respect to alternate hypothesis to reject the assumption. So the burden is placed on the researcher to show using sample information that null hypothesis is false, right? So if the sample information is sufficient enough in favor of alternate hypothesis, then null hypothesis is rejected. This is same as saying if the prosecutor has enough evidence of guilt, the innocence is rejected. And it is also possible that some error can be done in hypothesis testing. We defined this error in terms of type 1 error and type 2 error, which I am going to explain. Okay. After that, now this is called sampling distribution, which is a, you can think is a contribution of the previous session, but actually this concept is more useful in hypothesis testing rather than in sampling distribution. So there are different type of errors you can see. Now, one thing I am asking to you, like if I say, uh, you can go to the market, ask any 100 people, take the data of the 100 people and ask them what is their average income. So suppose 100 people go to the market and collect the sample size, collect the samples and ask their average income, right? So I have 100 subsamples. So ये 100 लोग हैं जो मार्केट में गए और लोगों से उनकी इनकम पूछी. So can I say the average income of all the people are same? All the samples are same? Can I say all the average of all the samples are same? The answer is no. The answer is no, right? So because two samples which may belong to the same population, but two sample mean cannot be same. Two sample mean may be same, may not be same. Most of the time they are not same. So if we calculate the standard deviation from this mean, if we calculate the, suppose this is the grand mean of all this is sample mean of first, this is sample mean of two, this is sample mean of three. So we are having the mean of the different samples, and if this is the grand mean. So if you calculate the standard deviation from this data, like every mean minus grand mean is square upon n minus 1. So this is called standard deviation of the sampling distribution, and this standard deviation is known as standard error. So I am defining here standard error. Standard error is nothing, it is the standard deviation of the sampling mean. But the problem is that we never have this facility to draw different samples from the population and calculate the standard deviation. So we have a approximation formula. This formula say that the sample standard deviation of one sample divided by n minus 1, this is called sampling error. So if this is the standard deviation of a sample, then we are using this formula, and if we know the population standard deviation, then we use this formula. So this formula is known as approximation formula to calculate standard error. And you may not believe that how much this standard error is important for hypothesis testing. Almost in every hypothesis testing, we are using the concept of standard error, right? So now I'm asking you some of the terms which uh, you may understand. One is called sampling error, right? So one of the concept is called sampling error. One is called non-sampling error, and non-response error. So I will explain you these two things. Non-response error, right? So there are different concepts: sampling error, non-sampling error, non-response error. So first is sampling error. Sampling error means because you are picking different samples, so some error may come by chance. Sometimes because of the sampling method, there is some error in the sample. This error, which is by chance error, this is called chance error. Sampling error is also known as chance error. So because whenever you pick any sample, it may be possible that its mean is different from the population, right? So this error is called sampling error. Like for example, if I say you that suppose in a college the average CAT score of the student is 98, right? So if you pick 100 students and the average CAT score is found to be 97, so in that case this difference of 1 is due to the chance, due to the sampling process. So we call this sampling error. So this standard error is nothing, it is a measure of the sampling error. This standard error is nothing, it is a measure of sampling error. So I hope you understand this. And I am giving you another example. Suppose uh, it is found that the average age of the cancer patients is 46. Like suppose this is given to you that the average age of the cancer patients in India is 46. Now you want to test it. So you take the sample of 100 people, 100 cancer patients, and calculate the average age. Suppose the average age is found to be 45 or 46, right? Or 47. So the difference between the population mean and the sample mean is because of the sampling method, sampling error. So this error is called standard error. I hope it is clear. And there are some errors which are due to other reasons. Like for example, if you change your research method, and because of the research method, the results may be different, right? For example, if you select the 100 patient and you are giving a medicine to them, and or if you are taking the patient from only Max Hospital, or if you are taking the patient from Fortis Hospital, it may be possible the sample mean is different from the population mean. So this is called non-sampling error, because this error is not coming from the random sampling. This is coming from the method which you are adopting in the study, right? So suppose you're sampling, you're adopting these convenience sampling, right? In this case the error may come from the convenience sampling method, right? If you decided to conduct this study in Delhi only, so it then some of the error may come because of this decision. So the error which is coming from your sampling method, your difference in the sampling method, so those errors are known as non-sampling error. And sometimes you are having the non-response error, because in one presentation, one panel member asked that what do you have non-sampling error in the study? So suppose if I ask you, you are conducting one research, and I'm asking you, uh, do you have non-response error in your study, right? So I know that at least 80% of you will not understand what is this non-response error, right? Because these terms are not very common in the research. In most of the books, these are not mentioned. But when I conducted a small research and find out the concept of non-response error, I found that when you collect the data from the public, right, there are many people who don't want to give you the data, right? If you go to the bank and ask the bank managers, sir, I want to collect the data from the people, suppose some employee say no to participate, right? So suppose if these respondent who say no to participate, suppose these people gives you the data, is will the result will change? Will the result will change? If yes, then it is called non-response error, right? I know that uh, when suppose I'm taking class in a university, I know that there is a group who don't like me, right? So I make all of my efforts to take not to not take the feedback from them, right? Because I want to exclude them. Why? So that my feedback will comes up. But the problem is that if these people who avoid or whom I exclude to take the feedback, if I included them, will the result will change? You say yes, definitely. So now I hope you understand what is the non-response error. Non-response error means the people who say no to give you the data, if by chance you collected the responses from these people, will you get the different results? So this is called non-response error. So in research, sometimes this non-response error is also important. So in the cases, you can say that we divided the error into two parts. This is called sampling error and this is called non-sampling error. This sampling error is called chance error because by chance you never get the result because of the population, because you are picking a sample, so some error is possible. That error is called sampling error. And there are non-sampling error because of your questionnaire is wrong, your sampling method is wrong, your behavioral effect, you are biased, you are already biased, or your respondents are biased. So then you will get non-sampling error. So as a researcher, you should take care of these errors, and this is by default. So sampling error is by default. You cannot manage the sampling error, but as a researcher, you should take care of non-sampling error. Actually, this sampling error can be adjusted with the hypothesis testing, but actually non-sampling error cannot be adjusted in hypothesis testing. So that is a problem in hypothesis testing, and we have to take care of non-sampling error as a researcher, because most of the researchers say me, sir, I'm not getting the reliability in my data, I'm not getting the validity in my data, I'm not getting the normality in my data. So all the problem are coming because of the non-sampling errors, I'm telling you. So if you are very, very cautious and careful in collecting the data, so you can remove most of these non-sampling error, and the error which is only there in the data is sampling error. So I hope you understand all the error terms, all the errors which are there, which are related to the sampling, and all the errors are affecting your hypothesis testing also. So now I am going to tell you how the errors are adjusted.